So our next speaker is Sunil Kandekar. Sunil is the CEO of NEAD Networks, and it is a successful new Alcatel-Lucent venture focused on data center network evolution. And Sunil is well known from leading the IP MPLS work in Alcatel-Lucent as a VP of business. And he came to Alcatel-Lucent from the successful startup T-Metra. Sunil. Welcome, Sunil.
Thank you, Luan. Good afternoon, everyone. I'm really excited to be here today. So like you, I traveled a long distance to be here. Yesterday, I landed at Charles de Gaulle, switched on my mobile phone, and within seconds, I was emailing, I was tweeting, I was chatting on the phone. The policies and the SLA that I have with AT&T back home were transferred automatically, and I had exactly the same SLA and the policy with Orange, which is where my mobile device connected. Completely different administrative policy domains, yet my service experience completely seamless, consistent, whether I'm in California, whether I am in France today, in Paris. Now, consider virtual machine workloads in private clouds, and consider the mobility of a virtual machine workload from a private cloud to a public cloud, separate admin domains. Or consider an application that stretches between two public cloud providers. And now think about, can those workloads or can that application get seamless SLA policies across those two independent admin domains? Most importantly, can that service be consistent across those two admin domains? Well, the answer is not quite. We're not there yet. Over the last year and a half at Nuage, we have been involved with many customers, helping them build private and public clouds that are highly automated, highly programmable, with a declarative policy engine that allows for any workload, whether it's a virtual machine, whether it's a container, whether it's a bare metal server, to be connected to the network automatically, instantly. And as we have gone on this journey, and as we have helped the customers deploy these private and public clouds, what has become apparent are the questions, the advanced questions about policy domains. How can workloads have the same consistent policies across admin domains? Different separate admin domains. So this is exactly what I want to focus on today. In the next few minutes, I want to talk about the journey we are on, the progress we have made in the last couple of years. Also talk about some of the trends that are underway as a result of this whole massive cloud transformation. And then I want to roll into and have a discussion on how we affect a consistent policy across different admin domains. So let's get started. So cloud has really changed the way applications consume. And really, the applications are consumed based on order and get, and not order and wait. And that journey really started with really the transformation of server virtualization, where you transformed your data centers, whether private or public, from a single tenanted physical servers that couldn't have mobility and were intense manual configurations to completely dynamic because of virtualized workloads, multi-tenanted, highly variable in the requirements of the services, and requirement to be programmable. So this particular cloud shift happened as a result of the entire transformation of how we view the cloud. And in support of this cloud shift, we had to do a networking shift. We had to transform the networks. We are not moving here. Sorry about that. Is there a problem? Okay. All right. Thank you. Thank you, Luann. So this is the cloud shift I'm talking about. The requirement to have and the response of the virtualization to make them multi-tenanted, virtualized workloads, lots of virtualized workloads, variable service requirements, and requirement to be programmable. In support of this, we had to transform the networks from static, complex, custom, costly, and closed networks that are hard to deploy, maintain, and administer to a completely automated network and networks which are multi-tenanted, which had 4 key tenets, if you will, in the SDN framework. And those are abstraction as in abstraction of the network capabilities, to allow applications to specify what they need rather than how those behaviors are implemented. Allow for automation of network provisioning, so zero-touch provisioning. Allow for full control over all workloads, no matter what kind of workloads they are, whether they are containers, bare metal workloads, or virtualized workloads. And of course, tremendous visibility in the network at the workload to allow for proactive and reactive network monitoring and changes. The calling of the day really was about focusing on the needs and automating the means. That's what we've done. So the trends then that are underway are these, and I'm sure these will resonate with you in terms of enterprises, very large enterprises, wanting to build private clouds that are highly programmable for all their infrastructure needs. The CIO of an enterprise doesn't want anybody to go around them and use AWS, violating all corporate rules. So they want to build an internal private cloud that's as good or better than AWS. That's the calling of the day. Similarly, pure play cloud service providers want to build public clouds that are, again, differentiated against AWS. That's the benchmark, if you will. NFV clouds is a recent phenomenon. And why is that? Because service providers are on a journey to identify what network functions make the most sense to virtualize, take advantage of the virtualization and the agility that comes with virtualization, take advantage of the Web 2.0 scale-out architectures, take advantage of the big data toolkit to allow for really network functions to be served from a cloud-based infrastructure. And finally, we're seeing this in terms of branch connectivity. A complete transformation. The branch networks, the classic hub and spoke branch networks, have stood still, literally stood still in terms of their architectures for over 2 decades. And for the first time, there's a tremendous amount of activity going on, requiring collaboration, multi-site collaboration that makes those hub and spoke architectures completely archaic and non-functional. And of course, the ability to have further services layered on, that requires a complete rethink of how branches are connected to the network, or how network services are delivered to branches, enterprise branches. Ultimately, the SDN phenomenon is about providing massive automation and a very high degree of simplified operation. That yields the business agility, which is the calling of the day. That's the high order bit. So we looked at this, and we looked at the problem and said, hang on a second, how can we apply the learnings of all the work we all have collectively done over the past decade in terms of building virtualized networks? VPNs are multi-tenanted VPNs using encapsulations, and we started with GRE encapsulations, L2TP, MPLS. There's all encapsulations available. We've done that, we've solved that in terms of creating that virtualized layer, which is on a common IP MPLS substrate. Second, we solved the multi-domain reachability problem, thanks to BGP. We've solved those problems, and hence the internet works and hums. And of course, in mobile, we solved the problem of a declarative mobile policy, where mobile phones are just automatically connected as soon as we switch them on. You don't have to walk up to a payphone and have someone connect your mobile phone to the network. So taking these learnings and then understanding that we had to provide a very high degree of automation, what we did was we transformed the data center architectures and brought them up to the cloud speed. And how did we do that? So let's start from the bottom. We took the learnings of MPLS overlays that we created in the wide area and applied them to create multi-tenanted overlay networks that go from hypervisor to hypervisor and that allow for multi-hypervisor connectivity, so independent of the hypervisor that's being used. It allowed for branches to be seamlessly connected to the private or the public cloud. Why did this happen? If you go up the next layer, it's the BGP controller or the SDN controller that's using BGP as the protocol allows for reachability information to be conveyed between different availability zones, or between the private cloud and the public cloud, or between the private cloud and the public cloud and the branch, to allow for what happened below at the data plane layer, a consistent, seamless, end-to-end network. Now, how did all this get instantiated? Well, the workloads get instantiated based on the policy that's sitting at the top. And how does that work? Well, anytime a workload comes up, and it doesn't matter, independent of the hypervisor technology, as the workloads come up, they get captured, the unique ID gets captured, they get authenticated and authorized by the policy engine, exactly like the mobile phones. And the network and the SLA that that particular workload has is communicated down through the controller to the hypervisor, to the vSwitch layer, and all the policies are then enforced at that layer, completely zero-touch configuration. This is what we've done. This is the work we've done. Now, not all SDN solutions in the market, of course, have this. This is a classic declarative policy-based automation, and not an imperative as some. So the distinction to remember is virtualization does not equate automation. In fact, virtualization will exacerbate the problem if you haven't changed the model of provisioning. All right, but that's great. That's the work we've done. But requirements continue to evolve. We are seeing going from distributed to hyper-distributed users as well as workloads. So users are highly mobile, as well as workloads. And thanks to containers and the very light footprint that they have, you can really pack them much more than you can pack VMs. And you can dispatch containers to the jobs rather than dispatch a job to the workload. The entire paradigm shifts, and as a result, you can have hyper-distributed environments. And then, of course, what I talked about in the opening, in regards to the single to the multi-cloud. How does a workload move from private to the public cloud? How does a branch get connected to a private cloud and public cloud, completely separate administrative domain, and yet maintain the same single seamless policy across all three separate independent domains? Or workloads in different clouds. How do they maintain the same exact SLA, same exact policy, and ultimately the same exact service seamlessly? What this mandates is clearly a multi-admin domain that requires to be solved at the policy layer. The initial focus, as I explained earlier, has been on a single admin domain. So we've done all the great work in terms of the automation, in terms of making it completely independent of the hypervisor layer, having the multi-tenancy based on whatever encapsulation, the flavor of the day encapsulation you need. We've achieved all that. What we haven't done quite is the multi-admin domain in terms of the policy layer. What we are doing by focusing on a single administrative domain is creating these islands of private and public clouds that are in and of itself highly automated. But when you cross the domain boundaries, admin boundaries, things don't quite work seamlessly. You need a manager of manager type of approach, which yields, which by definition means an imperative model, and things start to break. Now, multi-domain architectures represent new challenges, and these are largely driven by business requirements. So what are the business requirements? Well, it could be that I have a single domain, but within a single domain, I have multiple availability zones. And for each of those availability zones, I need highly resilient, highly available availability zones. And that means I can't have a clustered solution. And I'll get into more, I'll explain that a little more. Or ability to provide consistent service across different security policy domains that are dictated by enterprise branch locations and the provider that you're using. So you might have some locally applied policies based on the location of each of the branches, and you might have a provider that has a completely different policy model. Additionally, for provider to provider, you might have peering agreements that you need because the providers are not exposing their internals, if you will. And we've seen this, by the way, when we've done option A, B, and C in terms of how we solve that problem. But that's a different problem. We solve those problems of option A, B for VPN and network connectivity. What I'm talking about is how do you solve that at the policy layer with different admin domains. So what this mandates is really separate policy engines. All right, so let's take a look at what we've done so far in this journey. Well, I talked about how the private clouds and the branch and the public clouds can get connected seamlessly. Why? Because we're using BGP, MP-BGP protocol, which scales very well to provide this connectivity between different domains, if you will. What we haven't done is the top part. If you have, for this side, which is one admin domain on the left, that has its own policy engine, and on the right, you have a completely separate policy engine. How does that federation happen? To allow for a consistent service experience end-to-end between enterprise private cloud, between the NFV cloud, to the branch, and to the public cloud. Once again, we can learn from the mobile and how we solve this in the mobile networks. I talked about this in the opening. Endpoints can roam. And how do we do that? How does, and also in terms of the internet, how you advertise that a route is behind me? How can, in a policy federated approach, you can advertise that I am the authoritative policy owner for this particular admin domain. And when you get a request for some workload that comes into your domain, you proxy that to me because I am the authoritative policy owner for this domain. I will let you know for which domains I am the authoritative policy owner. Just like in the internet, you know, let them know that this route is behind me. So to drill down a little bit more, here's a suggested approach. For example, we can use the CAP theorem. in terms of consistency, availability, and partitioning, or partitioning tolerance. And what that means is within a single admin domain, so within a single administrative domain, you focus on, because in the CAP theorem, you can only achieve 2 of the 3. So you focus within a single admin domain on consistency and availability, because that's paramount. You should never go down within your admin domain. But between multiple admin domains, you focus on partitioning tolerance, because why? Because you're focusing on availability. That even if there's a partition, these are partitioned, things will still be available and work. And there's multiple ways there are multiple technologies, modern technologies available that have the pub/sub model that support very large social networks, for example, that we could use and leverage upon to convey those business locations, compliance, regulatory between policies, or to act as the proxy, as I said, as long as the other peer policy engine knows that you are the authoritative owner for this particular domain. So doing this, what we get is we get a network without borders. A network that allows for any service to span any network, whether it's an IPVPN network, whether it's a private IP network, from any branch, and independent of the administrative domain, you get a consistent end-to-end network services, and exactly what we've done for the mobile networks. But we solve this for the private public cloud or the branch connectivity, the trends that are underway right now. And this is the next journey, if you will, as we are, as I said earlier, as we get on this journey of having deployed multiple networks, having helped our customers deploy private and public clouds, as well as branch connectivity, network services. This is the next frontier that we collectively as a group need to tackle. Thank you very much.
Thank you, Sunil. I think Sunil brought up one very important point. Virtualization does not equal to automation. Until you can automate, it's very hard to operate to scale.
That's right.
Yeah. So appreciate your talk on the multi-domain policy engines. Questions for Sunil?
Hello. Lucas Paraschis from Cisco. Last year, you gave a great presentation about the role of SDN, very focused. And if I recall correctly, I'm not trying to put words in your mouth, correct me if I'm wrong, you said back then that the biggest, lowest hanging fruit, most important use case is the service orchestration, in some sense, and what you presented in the first couple of slides. And back then, you suggested that wide area network automation optimization may come later, but are not as critical. Now, as you talk about multi-domain, multi-administrative domain policies and so forth, do you retain the same conclusion about the wide area network automation optimization, or do you think, like the previous speaker from Ericsson, that that becomes much more pronounced as an SDN use case?
So here's the way to think about it. As customers build private clouds or public clouds, who's accessing those assets in those private and public clouds? Users. Where are the users? They're all the way in the branch. For them to get to those automated, highly programmable assets in the private and public cloud, you got to transform how they connect to those assets in the cloud. And hence the branch refresh is underway, and hence the requirement is so pronounced. And hence you need a policy engine that's common across both private, public, as well as the branch.
More questions?
All right.
Thank you, Sunil.
Thank you very much.